Okay, good morning. I guess still morning, just for a minute. So welcome to the last day of NDC Oslo 2023. Hope you've had a great conference so far. I know I have. My name is Jeff French, and I'm going to be talking to you today about managing Kubernetes the GitOps way with Flux. Now, this presentation has some nice interactive elements to it. So if you would like to, well, if I can advance my slides. If you would like to join the fun and play along, there'll be some times where you can kind of vote on some things or give your input. This will also allow you to ask questions throughout the presentation by simply typing them in. So you can scan the QR code, or you can go to menti.com and put in this code, and you can do that on your phone, on your laptop, smart fridge, whatever you brought with you. So let's start with the fun. Which is your favorite, pizza or tacos? These are the kinds of pressing questions that we come to NDC to answer, right? Let's see here. Oh, boy, pizza is out into a heavy lead. Tacos trying to make a comeback. All right. Well, let's close that voting up in about 30 seconds. Man, I'm really pulling for tacos. I wish I could vote because tacos are my favorite. Oh, here they come. All right, tacos, making that late showing. I like it. Okay. And these, the website and the code will be at the top of the presentation most of the time, so you can type it in and join if you haven't already joined the fun. But here we go. We're coming into the home stretch, and it looks like tacos is going to take it. Woo, all right. Yay, tacos. So, as I said, my name is Jeff French. I work for a company called MoonSwitch in the States. We are a DevOps consulting firm specializing in cloud migration and modernization, managed cloud and Kubernetes, DevSecOps. This is what we do all day, and this is why I'm here to talk about GitOps, because it's what I do all day, and I love it. I'm passionate about how much it has had a positive effect on the way that I manage environments for our company and for all of our customers. And so the things that I'm going to talk to you here about here today are things that have been battle tested in production with multiple clients, multiple workload types, multiple clouds even. So one more fun little interactive one. Let's find out where you already are with some of these technologies. And we'll just take about 30 seconds to vote on that real quick. So now, to give you a little bit of my background, I've been practicing DevOps since kind of before we had the word for DevOps. In fact, I'm kind of excited to be speaking here at NDC Oslo 2023 again, because the first conference presentation I ever gave was at NDC Oslo 2013, where I was talking about deploying complex apps continuously with Octopus Deploy. And so for the last 10 years, I have been doing what became known as DevOps over that time, with continuous delivery and enabling application teams to deliver their applications to the cloud or to their servers, efficiently. All right, so it looks like we are kind of across the spectrum on Kubernetes experience. That's cool. And staying low on the customized Helm and Flux. Well, that makes a lot of sense. That's why you came to this talk, right? You want to learn about these things. So, before we get into Flux and GitOps itself, we've got to lay a little bit of a foundation with some of the other technologies that are involved in managing a GitOps configuration with Flux. And the first of those is Kustomize. So, Kustomize is a standalone tool for customizing Kubernetes objects through declarative configuration language. And it's been built into kubectl since version 1.14. It also has its own standalone CLI as well. And this is written and maintained by the Kubernetes team. And Kustomize, its whole mission in life is to gather up your Kubernetes resources, make small modifications to them, and then help you apply them to your cluster. So what are the benefits? We've got, obviously, declarative configuration management. That sounds really good if we're trying to do GitOps, right? Because we're going to want to declare exactly the state that we want our clusters to be in. Reduced duplication. As we'll see, Kustomize can help you organize your application and all of your Kubernetes manifests in a way that helps you keep them a little bit drier and keep them more consistent across environments. And it helps you with the separation of concerns across your different environments or different applications. So, basics of a customized configuration or a customized app, as I like to call them, are, number one, a customization file. It's basically always called customization.yaml. And it is a definition that tells the Kustomize CLI how to transform your application and how to transform your resources before you actually apply them to your cluster. In this file, you will define which resources you want. And then you can organize these into some interesting structures called bases and overlays. Okay? This is where Kustomize starts to help you dry out your configurations a little bit. You can create a base that has all of the common configuration for your application that's going to go to every single environment, right? So in your base, you might define a deployment.yaml that defines a Kubernetes deployment, probably a service and a service account, maybe some config maps, all these things that it takes to deploy your application into any Kubernetes cluster in your environments. And then we've got overlays. So overlays is where we actually store environment-specific modifications to that base. Your overlays will reference a base and say, hey, I want you to go get everything that's in that base, and then I want you to apply these changes to it. So some of those changes and things that Kustomize can apply from those overlays or in the base. Patches. Patches are a really, really helpful one in Kustomize. It lets you say, hey, I know we defined this way up in the base, but for the dev environment, it needs to be just a little bit different. Or for the prod environment, it needs to be slightly changed. Some of those common modifications might be, let's say you define an ingress in the base of your customization. Well, in your ingress, you probably need to define a host name for that ingress, and that host name is probably going to be different in dev and stage and prod, right? So patching there will allow you to say, well, I can define most of my ingress at the base because the service names and the ports and the paths and most of the configuration is actually the same, and I don't want to have to repeat it everywhere. But I just want to change this one little piece. So you can write a patch in Kustomize that allows you to modify just that. Another option might be, say, changing the replicas. Maybe we only want to run one pod for a deployment in dev, but we want to run 100 in production. Config maps and secrets. This is another one that I really like to use in Kustomize because it can generate them. It can either make them up out of nowhere based on some values that you give it, or it can take existing config maps or secrets and modify them. And this is a really, really powerful tool in Kustomize. One example of this would be if you've ever deployed a deployment, a pod on Kubernetes, and configured it to read maybe a file or even better, an environment variable from a config map or a secret. And then it was time to change that environment variable. So you went and you updated the config map and you put the new value in. Great. And then you go back and your pod is just still got the old value. And we know why that is. If you're on the right-hand side of that Kubernetes spectrum, you probably already know this. If you're on the left-hand side, you have to go restart that pod. That pod reads its config map value at startup, and it's not going to change the environment variable once the pod is running. So you have to go roll out your deployment or delete your pod and let it restart so it can pick up that new value. And that's really easy to forget to do when you're checking this into Git and letting it get applied automatically. Well, one of the cool things that Kustomize can do and does this by default, is if you let it generate a config map, then it will actually change the name of that config map. It will append a hash of the contents of the config map, or the secret, to the end of the name. And that way, every time you run your customization, if that hash has changed because the contents have changed, it will change the name. And that sounds great, but now you've got to reference a new config map name in your deployment, right? Well, Kustomize has got you covered. It knows where config maps and secrets get used in all the standard Kubernetes objects, like deployments, pod specs on stateful sets, daemon sets, jobs, cron jobs. And so it will go and say, hey, every place that you reference this config map by this name, I just gave it a new name, so I'm going to go update that for you. And this has the really nice effect of causing a change to your pod spec on your deployment or stateful set, which will naturally trigger your deployment's rolling upgrade whenever it gets applied. So now, by simply making a change to the config map and then applying it with Kustomize, it will automatically make sure that all of your pods pick that change up correctly. It's a very, very powerful tool. You can also do some light variable substitution. I wouldn't get too deep with that, but it can be helpful in a few small scenarios, but usually a patch is probably a better approach in most cases. So, the root of our customization is a customization file. As you can see, it looks just like a Kubernetes object, right? We define it in YAML just like we would a deployment or a service or a config map. And here we're defining that we've got resources, and we're just telling it, hey, pick these up. Now these, as you might guess, deployment, service, ingress, those are just YAML files that have standard Kubernetes YAML in them. They could be applied directly to your cluster using kubectl apply-f and passing in each one of those file names, and they would be applied straight to your cluster. Kustomize takes those and is going to actually combine them into a single YAML output for you. So you can either run Kustomize and see what it's going to do and have it actually generate a full output that you can inspect. You could even take that, and rather than letting kubectl apply it for you, you could save that as a full output and apply it yourself. Now, I mentioned that kubectl has built-in support for Kustomize, and we see this in the bottom of this slide here, where you can use kubectl Kustomize as a command to actually run your customization and see what the output is going to be, test that it's actually updating your config maps and things like that. Or you can also just run kubectl apply, but instead of -f, you can say -k and feed it a customization file or a directory that contains a customization file, and kubectl is going to automatically go and run the customization, render it into its final form, and then apply it to your cluster. Now, here is a common way that I lay out most of my Kubernetes or my Kustomize applications on the right here. And as you can see, we've got a pod info app, and I always like to define a folder called base and put all of my base resources in there that are going to be common for every environment. And then a folder called overlays, and under that, a folder for each environment that I'm going to deploy to: dev, stage, prod, QA, wherever. And in our base, we'll define a customization.yaml that defines most of what is going to be picked up and generated and made for our app. And then down in each overlay customization, we put in just the parts that need to be different for that environment. Okay? And that might be generating or merging a config map or secret to set a special value. That might be putting a patch in there to change some value before it gets deployed. Another nice feature of Kustomize is that it can automatically update labels and annotations. It can help you avoid naming collisions by doing name prefixes, right? And so one common use is using, say, common labels to say, well, okay, I want all of these labels on my base for every deployment. I want to know what app it is and maybe all these other things. But for a specific environment, I want to know that its environment equals dev, right? And so I can go apply that at the dev overlay, and that label will get applied to all of the resources that Kustomize processes in that configuration. Okay, so So that's the basics of customize, right? And we can already start to see how, okay, well, if I can have all of these YAML files and I can make them special for each environment, I can then obviously check these into a repo. You can see how this starts to lay the foundation for GitOps, right? Because we are going to store all of our configuration in a Git repository. Customize is a great tool to help us achieve that. Okay, so lots and lots of fun info about Customize. Let's get back into some of our fun interactive stuff. What have you enjoyed the most at NDC so far? Oh, man, it's hard to say, but I think my favorite was probably the continuous food. It's very nice to be at a conference that's always help, making food available. And coffee. Pretty good coffee, too. Yeah, the food's making a strong... Oh, people are here for the sessions. You guys came to a conference for the sessions. I'm very happy to hear that as a speaker. All right, just a few more seconds. And, yeah, all right. Is continuous food going to make a late push? Let's see. Okay. Oh, continuous food coming in at the wire. All right, I knew we'd get you. Okay, so another technology that we want to make use of when we are exercising GitOps with Flux is Helm. If you are operating Kubernetes clusters, you're probably familiar with Helm, but according to our pre-workshop survey, not as much. So let's dive into Helm just a little bit. So Helm is often referred to as the package manager for Kubernetes, okay? You could kind of think of it like, it's not the same as, but similar to something like apt or yum for operating systems, or maybe npm or NuGet for application dependencies, right? It's a place where people can publish Helm charts that have a configuration that is ready to deploy onto your cluster, okay? They help you manage your Kubernetes applications, and they help you define and install things. So what is a Helm chart? Okay, it's bundles of pre-configured Kubernetes resources. And it can be deployed multiple times inside of a cluster, and most importantly, it supports Go templating for customization. So we just talked about Customize and how it could gather up all of your Kubernetes resources and help you make some modifications to them. So why do we need Helm? Well, first off, Helm is a little more powerful, mostly because of the Go templating. You can do a lot more powerful things inside of a Helm chart to vary the output of the Helm chart based on inputs that we'll get into here in just a little bit. But also, the Helm chart is a very good way to package what I like to consider, say, off-the-shelf software. In Kubernetes land, what I mean by that are basically things that I didn't write, okay? I don't want to have to maintain a whole bunch of Kubernetes object definitions for my ingress controllers or external DNS or cert manager, any of these things, right? I would like for the maintainers or even vendors of those products to maintain that for me, all right? But they have to be able to support a wide range of options, so Helm gives them the power to package this up in a way that's easy for you to install on your cluster with a little bit of variance based on some inputs and be able to manage those efficiently. So, what is a Helm repository? A Helm repository is, you guessed it, it's where we store Helm charts, right? And it's really just kind of a folder with an index.yaml in it that points to a bunch of tarballs of all of the different versions of a Helm chart that are available. So some of the common Helm commands, and these become important because we're going to automate them, are Helm install to install a chart, Helm upgrade to upgrade a release. They're very straightforward. But you can see how this really works very similar to other package managers, right? You simply say, hey, I want you to go to some repository of packages. I want you to find this one that I'm interested in, and then I want you to perform these operations on it. So, one of the most important parts about Helm, for our purposes, is understanding the values files. We're not going to get into how to create Helm charts here today. That's well beyond the scope of this talk, but we are going to talk about how to deploy them, and values files are critical for that. So value files are YAML files that are used to customize the configuration of a chart. Okay? Every chart has a default values.yaml file right in the root of it that defines all of the default inputs there. Those inputs are used in the Go templates inside the chart in order to alter the actual resources that get created based on those inputs. All right? So you can then provide your own custom configuration without needing to modify the chart itself. So you can specify your values in a lot of different ways during installation. My favorite, and the one that we will be kind of talking about a lot today, is using the -f or values flag. This lets you have your own YAML file that defines the inputs that you want to define for that chart and set the appropriate values, and then pass it in on the command line, and Helm will read all those values and apply it to the chart. And the other fun part here is that multiple value files can be passed in. So you can say -f values, and pass in multiple charts. And what will happen is that Helm will munge all of those together. All right? So anything, the last file you pass in ends up winning. It's a last in wins kind of command line option. And therefore, if there is the same key in your YAML file defined in the first values file that you pass in, and another one defined in the second values file that you pass in, and they're the same key, then the last one is going to overwrite that. It's going to clobber the first one. And this is going to become very important for us in the way that we maintain bases and overlays. So as I said, this is what that ends up looking like. You can run a Helm upgrade with a -- install, so it says, hey, upgrade this if it's there, install it if it's not. And if I pass in my values and my other values, anything that is in my other values can clobber what is in the my values file. But anything that doesn't have the same key will simply get merged together into a single YAML file. And finally, when we're running these commands, we give it a release name. So this is what's going to be used to identify the release in your cluster. And then we're telling it, hey, here's the Helm repository that you should look for this in, and here's the Helm chart I want you to find. And there's lots of other command line options. You can pass in versions and all of that. So some tips and best practices on these. Store your values file in source control so you have a record of all your changes, right? They're just YAML. Now, again, apply all of your normal code repository storage security measures. If the Helm chart takes an input for, say, a database password, don't check that into your repository, please. There are other ways to handle that, and we'll talk about that a little bit when we get to Flux. You can use a hierarchical structure in the YAML file to organize everything, and lint your YAML files. They are YAML. If they are not valid, Helm won't know what to do with them, and it might fail in some really interesting ways. All right. Let's have some more fun. This one might be spicy. Yeah, I thought maybe I'd go with tabs versus spaces, but that's an old fight. Nobody wants to have that fight anymore. Uh-oh. Here we go. AWS making a late comeback. Oh, I forgot to start the timer. Well, we don't need to wait that long, but why not? 30 more seconds. So I'm not surprised to see Azure's out strong. I know Azure is a very popular cloud among NDC attendees. We do work on both Azure and AWS, and they both serve their purposes. All right. Well, it looks like, although I will say this, AWS is my favorite. Shh. Doesn't look like my favorite's going to win this time, though. Wah, wah, wah. Okay, so the main event. This is what you came for. What is Flux? What is GitOps? Let's dig in. Okay, so we'll start by just defining what GitOps is, okay? That's better. So as you can see, it's a Git-based approach to managing infrastructure and application deployments, serves as a single source of truth for your infrastructure and application configuration. But what are the benefits of GitOps? And real quick, let's talk about just the word GitOps. GitOps is kind of like the word DevOps, okay? It's not a thing, it's an idea. It's a collection of practices, it's a culture, it's a mindset, okay? You can achieve GitOps with lots and lots of different tools, okay? Today we are going to talk about Flux, but there is also Argo CD that's a very popular GitOps framework in the Kubernetes community. You can also achieve the benefits of GitOps with just your regular CI/CD system by simply following and you gain all of these benefits, all right? We get consistency. We want to make sure that our environments are configured consistently, right? Just like we want our dev environment to be as close to our prod environment as possible so that we can test our applications correctly, understand how they're going to behave, right? Collaboration, okay? Because we are storing all of these in a Git repository, we get all the benefits of, say, pull requests. When someone wants to make a change to some of our configurations, they can submit a pull request. We can have a discussion about what that change means, what its impacts are, why that change is being made, make sure it's the right change for our organization or for our application. And then, of course, it provides us an audit trail, right? We can come back and see what changes have been made, by who, when, and why. And it helps simplify rollbacks if things go wrong, right? We could just revert that commit, go back to our last state. So there are a few principles of GitOps that will kind of help guide you if you are trying to implement GitOps with Flux or any other tool set. Declarative configuration, version control, and automatic convergence. So, first principle, declarative configuration. Define everything in declarative configuration files. Much like what we've just been looking at with Customize and Helm, there are ways where we can take our desired configuration state, express it in a file that can be checked in to a Git repository. That way and by doing so, we are stating this is our desired state of this environment or these environments. We're saying this is how we want things to look. Version control. Store them in a version control system. Probably Git. It's kind of the most popular one these days. It's right there in the name GitOps, but spoiler alert, if you are using something else, you can still achieve the same GitOps principles with, I don't know, SVN or something like that if you're still using something like that. The idea being that as long as you have some sort of source control repository where you can store your configuration files and create that audit trail and that collaboration and that consistency, you can still achieve GitOps. You're not going to be able to use Flux to do it. It really only works with Git and S3, but. And finally, automatic convergence. All right? This is the real key to GitOps, automatic convergence. It's one thing to say, I've declared my state in a repository, and we said that that's what we want. And maybe our CI system ran and applied that state to our clusters. But if it's not continuously doing that, you're not really achieving GitOps. Okay? Automatic convergence is using some kind of tool to constantly be reconciling the state of your cluster with what is defined in your repository. Okay? So Flux is a tool that's really going to help us achieve that. But again, you could achieve this with a CI pipeline as long as you schedule that CI pipeline to run maybe every 5 minutes or 10 minutes or something like that so that it's going back and applying these states. All right, so that brings us to Flux. So what is Flux? Open source GitOps toolkit for Kubernetes developed by Weaveworks and part of the Cloud Native Computing Foundation. And it monitors Git repositories and automatically applies their changes to the cluster. I'm not 100% sure, but as far as I know, I think the Flux team kind of was one of the originators of the GitOps term. I could be wrong, and now that I've said it at a conference session, I'm guaranteed to be wrong, and someone will correct me. But I like to learn, so please do if I'm wrong. I think a quick note on the CNCF. I don't have an interactive slide for this one, but quick show of hands of who's familiar with the Cloud Native Computing Foundation. Okay, maybe 50%. So the Cloud Native Computing Foundation is a division of the Linux Foundation, and it's basically a board that helps kind of identify up-and-coming projects that are good in open source for cloud native computing objectives, and sort of guide those projects through their governance model and how to build their community until they get up to a state where they are actually considered a graduated project. And what's really cool about that is it means that they are kind of making sure that these projects have good open source governance standards. They've got active, committed maintainers. They've got a thriving community of people who are both contributing to and using the project. The idea being that if a project is in a CNCF incubator stage, it's pretty good, and if it's in a graduated stage, you can be pretty confident in taking a dependency on that project because it's going to be well maintained over the course of time. Kubernetes is probably the most well-known and first graduated CNCF project. Flux is a graduated CNCF project. There are lots and lots and lots of others on their website. So, what is Flux? What are the components of it? It is a set of controllers and CRDs that get installed into your Kubernetes cluster. Okay? So when you bootstrap a cluster with the Flux CLI, it goes and applies a whole bunch of CRDs for things like Git repositories and Helm repositories and customizations and Helm releases that it knows about. And then it deploys a set of controllers that know how to actually interact with those objects as they get defined and take action based on them. Okay? So there's a source controller, customized controller, Helm controller, notification controller, and image automation controller. It's actually 2 controllers. Let's dig into them a little bit. So this is a little diagram of how the source controller works. So as we can see, on the left side of the slide here, there are some CRDs that get deployed with Flux, Git repository, Helm repository, and bucket. And they are definitions of where to find and how to access each one of those types of objects. And that lets the source controller go and clone a Git repository and constantly sync from it, or load a Helm repository and constantly sync all of the charts that are in it, or load a bunch of files from an S3 bucket. Those objects get created with the Kubernetes API. The source controller sees that and then goes and follows those instructions and says, hey, I know how to do this. I'm going to go get it. And then there are consumers, which are the other Flux controllers of those artifacts that are then going to take action based on the fact that there are new things found in these sources. Okay? So, and they will then produce artifacts that can be deployed throughout our cluster. The customized controller, it's aware of Git repositories and customizations. Okay? And so its whole job is to take those customizations that we defined earlier with customize and actually continuously apply them to our cluster. Right? So we take all those customizations that we wrote for our app, we check them into a Git repository. That Git repository is registered with Flux. The source controller sees an update to it, notifies the customized controller. The customized controller says, oh, I know what to do when there's new files. Converge automatically, automatic convergence. And it picks up and runs those customizations and applies them and ensures that, and creates all of the normal resources you would have in your Kubernetes cluster. CRDs, namespaces, RBAC, all of these things. The Helm controller, I think you can see where this is going now. It does the same thing with Helm charts, right? So we can then define these Helm repository and Helm chart and Helm release CRDs in our Git repository. And when we apply those to our cluster, the Helm controller will see them and say, oh, I know what to do with this. You're telling me that you want me to go get this Helm chart out of this Helm repository, apply these values to it from values files, and run that on and install it in the cluster. This one also includes a part of the diagram that's really interesting, and I just took these straight from the Flux website, so I didn't make these diagrams. But they actually all do this, the notification controller, which we'll get into in a minute. But that's the interesting part, is that it can give you notifications about things, actions that are being taken by the other controllers. Oh, what have we done? Okay. The notification controller. So the notification controller can do two things. It can receive webhooks, and then it can dispatch notifications. So the receiving of webhooks is kind of cool, because while the source controller, if you give it a Git repository, it will, on an interval that you specify, go and pull that repository to find any changes. But you can also register a webhook receiver with the notification controller, and then you can register that webhook with your, say, GitHub repository or GitLab repository. And that way, rather than the source controller having to pull and wait 5 minutes or however long your polling interval is, it can instead just receive a webhook and know that it can go and reconcile those changes immediately. And then once the other controllers take actions, they will, such as a customize apply or a Helm upgrade or install, those will surface events to the notification controller, and you can then register dispatchers that will dispatch those notifications to various places like Slack, Teams, Discord, Rocket Chat. There's a whole host of places. I think you can also just have it drop a webhook to something. All right. And then the image automation controllers. So by default, Flux doesn't actually deploy the image automation controllers. You have to kind of opt into that. It's a little more advanced use case, and it works in a way that you have to kind of determine your organizational appetite for risk on what you're letting things be automated for. But the image automation controller, it has a reflector controller and an automation controller. The reflector controller fetches tags from Docker repositories. So you define Docker or OCI repositories. It will constantly check them and see when there are new tags pushed to those. You can then write an image policy that says, hey, whenever there is a new tag in this Docker repository that matches this criteria, I want you to select that as the new tag. It doesn't do anything with it yet. We'll get to that in a second. But you can define that, and it can be based on either semantic versioning. It can be based on a lexical sort. You can tell it, I always want whatever the newest one is. And there are different reasons to do those for different environments. But once it receives a new tag, it will then go and read configurations that you have in your Git repository called image update configurations or automations, and take action on those. And the common one is by placing a specially formatted comment that you can see on the Flux website into your YAML configurations, it can go update Docker tags. So you can either put this special comment right on your deployments or stateful sets or jobs where you want a particular Docker image tag to be updated, or you can use a feature of customize that will update image tags throughout your customization by specifying it in your customize file. Or you could maybe put this comment in a values.yaml file for Helm that specifies an image tag that you want updated. And whenever that policy that you defined, let's say it was semantic versioning, sees a new tag that is newer than the previous one and meets your criteria, the automation controller will go and find that file or all those files in your repository, make the change to that tag, and then commit it back to Git. Now, it can do so on the same branch it read it from, which is going to trigger things to just roll out automatically right away, or you can have it commit to a separate branch. That way you could use a pull request process in order to actually approve that change. But when it the important thing to note is it does not actually make changes in your cluster. It makes a change to your actual declared configuration in the Git repository, commits it back, and then on the next Flux sync cycle, Flux says, hey, there's been a change to this image tag. I'm going to apply it via customize. I'm going to apply it via Helm, right? It's still maintaining its own GitOps principles of, hey, we're not just going to do magic stuff here, with some minor exceptions, but we're going to actually declare this stuff. The one minor exception I would put in there is that when you are defining semantic versioning for a Helm chart to be released, you can use semantic versioning selectors there and tell it, hey, I want you to just go ahead and install a new version of this Helm chart whenever these conditions are met. One I'll do with that a lot is for projects that I kind of trust, like maybe Ingress Nginx or Cert Manager that have shown a pretty good history of making reasonable semantic versioning choices, I might go ahead and let them automatically install patch versions of those charts, just so I'm kind of getting updated bug fixes and security releases without having to think about it. But for minor versions or major versions, I want to control that. Okay, so we talked about the customized controller and that there's a customization CRD. So an unfortunate choice was made in the beginning of the Flux project. I can see how they got here. They said, hey, we want to have a controller that needs to go and deploy customizations that are built for customize. And so what are we going to call our CRD that tells our system how to deploy a customization? We're going to call it a customization. I really wish it was called a customization release or something like that, but it's not. So as you can see here, if you're looking closely, we have two different Kubernetes objects that each have a kind called customization. They differ by their API version. The one on our left is customize.config.kh.io. This is the regular customization that we talked about at the top of the presentation. Okay, this is the one that can go and do all those customized things. The one on the right is Flux's version, okay, and it represents a set of instructions that tells Flux how to go find the other customization and apply it. It's a very unfortunate naming overlap, but we will just have to live with it probably until Flux v3 at least. I don't know if there's any momentum on getting it changed in the community or not, but that's what it is. Also, I guess real quick, I do see somebody asked a question about CRD. So a CRD in Kubernetes is a custom resource definition, okay? And that is basically a way that anybody, but generally open source projects or vendors, can create new types of Kubernetes objects, all right? These are both examples of CRDs. Well, customize is technically, the customization on the left is built into Kubernetes because it is built in by the Kubernetes team. But the one on the right is an actual CRD, a custom resource definition. So this is where the Flux team wrote, and if you've ever seen a CRD, if you haven't seen a CRD, don't. They are literally thousands, in some case tens of thousands of lines of YAML to define these things. You don't want to get into that. You don't write them by hand. They get generated from Golang code. But you define customizations, and it's basically a set of instructions to the Kubernetes API that says, hey, here's a new object that I want you to be able to maintain on our cluster. All right? I want to be able to create these types of objects, and I want to have things respond to them. Right? So, all right. So let's dig into one of infinite possible repository structures when you're using Flux, okay? This is the one that I use all the time. This one has served me well for several years. It has been battle tested, and we'll take this through top to bottom just a little bit. What I like to refer to this as a platform repo, okay? So typically whenever, especially if you are, say, a platform engineer that's supporting multiple dev teams throughout an organization, it can be a good idea to have your own repository that defines all of your configurations for your different environments, for your infrastructure. In a platform repo, I will typically store all of my Flux configurations like this, as well as Terraform. That's beyond the scope of this talk, but here's what we've got. So I'll usually have a top-level folder called apps, and under that I place, you guessed it, apps. Here we've got an example of this pod info app that has the same structure that we identified earlier. We've got a base with all of our common deployment and service resources and a customization. This is a customized customization that defines how to pick up all those resources. And then we've got overlays for dev, stage, and prod, whatever other environments we might have. And each one of those has a customization, another customized customization that references the base and says, here's how you deploy pod info for dev or stage or prod. And then we would have other app folders for all of our other applications, back end, front end, whatever all these applications are that need to be deployed to your cluster. We would put those there. Now, a common question I get is like, well, does that mean we're going to a mono repo? No, not necessarily. All I store in this is just the YAML files for Kubernetes. I'm only storing the things that tell how to deploy the Kubernetes objects. The application source code is not here. You could replicate this structure inside each one of your application repositories if that works better for you. And you can have Flux point at each one of those different repositories to find what it needs to be applying. Okay? I prefer, based on the way that I interact with my systems and my client systems, to have it all in a single repository that is decoupled from the application code. I then have a cluster services top-level folder. Okay? So cluster services is something I define as basically all the stuff that needs to run in your Kubernetes cluster that's not your actual applications, right? So ingress controllers, cert managers, cluster autoscaler, maybe Prometheus and Grafana for monitoring, log collection, all of these kinds of things are what I call cluster services, right? They are sort of the things that are helping your applications be able to actually run in a Kubernetes cluster. And I'll store those there, but you'll notice we're using the exact same structure here. But you'll notice I've got a helm.yaml here. For cluster services, I almost always try to deploy those with Helm, right? Those are full-on projects that are maintained by teams outside of my organization that I want to just be able to install via a Helm chart, all right? And then we'll see down here, there's overlays where I can customize each one of those. I've got a values.yaml file here in the base. I can also have a values.yaml file down in the overlay so that I can set up the exact type of command that we talked about earlier, where we've got our values.yaml, our base.yaml, and our overlay.yaml that are coming in to our Helm command to modify that for a particular environment. And then a little bit hard to see down here, but at the bottom, this clusters folder at the top level. And in that clusters folder, I'll have a folder for each environment, each cluster that we operate, right? Typically, I map each cluster to an environment, so dev, stage, prod, again. You'll see it's got a Flux system folder in there. That has a whole bunch of stuff in it that is generated by Flux. When you bootstrap your cluster, the Flux CLI will generate all these for you, put it right in your repository, maintain it there. But then I have two interesting files here, apps.yaml and clusterservices.yaml. And as you might be able to see down here at the bottom, those are called out as Flux customizations, all right? So my apps.yaml file is typically one file with several Flux customizations in it that point to each one of the applications up in the apps folder, all right? So in the dev cluster, I'm saying I want you to deploy these apps, and in the dev cluster, my apps.yaml will point to the dev overlay for pod info. In the cluster services.yaml, my Flux customization will point to the dev overlay for the Nginx ingress, or for the ingress Nginx cluster service. This really, once you kind of wrap your head around this structure, it really kind of starts to make a whole lot of sense and makes it very easy to go look and understand which things are being deployed into a given cluster. What configurations do they have? How do those configurations vary between environments, right? But you can also see how it starts to give you a ton of consistency across your environments, okay? You now have almost everything for each one of your applications or cluster services defined in a common place with just a little bit of variance per environment, also defined in a common place. Easy to reason about, easy to collaborate on, easy to compare the differences between environments on. Now, one more thing, and we will actually go ahead and drop right out to GitHub to look at this one because it's a little bit easier. But here I have a sample repo that has the very structure that we just looked at, and I'm going to show you what one of my cluster services looks like for external DNS and how we apply some of the features of both Customize and Helm in order to change this across deployments. So in this helm.yaml file, I've defined a Helm repository at the top. I'm telling it I want to go look at the Bitnami Helm chart repo to find Helm charts. And then down here, I'm defining a Helm release. And this tells Flux's Helm controller that I want you to go do a release of the external DNS Helm chart version 6.20.x. Like I said, I let them do the patch releases. I trust them. From the Bitnami Helm repository. It's got a little bit of configuration that says, okay, if something goes wrong, I want you to retry it at least 3 times on an install or an upgrade. Now, the really interesting part here is this values from section, okay? This values from, and I'm telling it, hey, I want you to go get values from a config map called external DNS values, and I want you to get values from a config map called external DNS overlay values. And this one, I normally mark the overlay values as optional. I don't in external DNS, and we'll see why in just a minute. But this lets me take my values files that I'm storing in my repository, use Customize to generate a config map that contains that values file as a key, right? And then when I've defined this on here, that tells the Helm controller, go to this config map, pull that values file out, and use it when you construct your Helm install command or Helm upgrade command. And it's going to use these in order. So my base values is going to be first, and my overlay values is going to be second. That allows my overlay to modify the base. Now, the other interesting thing, remember I told you that the Customize will append hashes onto our config map names. You can also do this with secrets, by the way. Important to note there. So if I go look in my base, we'll see that I have not defined the file I want to show you. Well, let's look at a different one then. I think it's in here. I've got this customized config. Because the config map generator and secret generator, they know all about the built-in Kubernetes objects, so they know where to find references to the config maps to update them. But they might not know, they absolutely do not know, about custom resource definitions, right? There could be any number of custom resource definitions in your cluster, and they can't keep up with that. So here, you're writing a configuration that says, hey, whenever the config map generator runs and generates a new name, also look for a Helm release object, and at this path in the YAML, update the name. Same with the secrets, right? And you can do this for any other types of custom resource definitions by simply creating a configuration file and referencing it. Now, let's go back to our cluster services and look at external DNS and see how it is that we're modifying this. In our base, we've got a values file that just sets our log format to JSON. It's the only common setting we really needed to set for this. Nice and simple. I want that in all environments. But if I come to my overlays and look at dev, my values file here, I've got, and this is just an example, so I don't actually have an ARN here, but I'm telling it some different things. I'm telling it, oh, hey, this one is in the EU North 1 region of AWS with a public zone. It also needs these other values to be changed. It's a service account that I want to apply an annotation to. Obviously, that annotation is going to have to change between every environment, right? So I need to define those at the overlay level. And that way, this can all get munged together and create a way to deploy my external DNS Helm chart into dev or stage or prod with the appropriate credentials. So, question we answered on the CRD. Yep, that one is answered. Can you point Flux to Prometheus or Nginx ingress Helm chart and at the same time read the values file you have created in your own repo? Yes. So I think the question there, which I don't know when that came in, maybe that one was already answered by what I just said, but that's what we were just going over, is that I'm storing these value files in my repo, and I'm saying go fetch the Helm chart from their Helm repository, but ultimately what Flux is doing is constructing a Helm upgrade command, really, and it's going to say Helm upgrade, and it's going to take the values that I pass it here and perform that install. All right. Is that repo public? Yes, this repo that we're looking at here is in fact public. It is, and I will drop the link to it in the room Slack channel here, but it is at github.com/moonswitchworkshops/terraform-eks-flux. I gave a 2-day workshop on managing clusters on AWS with Flux at the beginning of the conference, and this is sort of the almost final state of that workshop for those who went through it. And you can reference this, and it's got most of this information in it. All right, how do you stage updates to different environments to make sure updates are first tested before being released to production? That's a great question. We use overlays. Because we have an overlay for each application and a separate configuration for each cluster, we can say, you know, if you're looking at, like, let's talk about, say, the Helm chart version, right? If we had our Helm chart version of 6.2.3, right? Or an image tag version defined in our base, right? We want to actually change that from the overlay. And we would do that in a number of ways. A really common one would be a patch, right? So I can have a version defined in my base, and then my overlay, I can write a patch that says, okay, well, only for dev do I want you to try changing the Helm chart version to 7.0, and let's see what happens. Or only in dev do I want you to put this, you know, git commit SHA-based Docker tag out there from our latest dev build and see how that works. And if it works, then we will look at checking that change into the other environments in order to actually propagate that change. All right. How do you do promotion of application releases between environments in the folder structure? What I just talked about right there, you simply write your patches, move them down through, and ultimately, you know, once you get to where that same version is in each environment, then you would just check in a change that puts that version at the base, and you're ready to go through another cycle again. Let's see here. What is the main difference between Argo CD and Flux? Well, Argo CD has a GUI by default, and they do a lot of the same things, but they take some slightly different approaches into how they develop their graphs and which features they actually support. I've found that I've had more consistent reliability with Flux than I have with Argo CD. I've used both. I still use both. I actually have some. There are some features of Argo CD can do some interesting things with reading JSON files in order to generate multiple configurations. So I've used that to set up dynamic, like, QA lane deployments for some clients, even though I manage the rest of their cluster with Flux. Is there any particular reason you would choose Flux over Argo or any other? Same reasons I just said there. I choose Flux first. I only go with Argo if it can do something that Flux can't, and those things are very, very limited. How does Flux work when it comes to client pull versus server push? By default, Flux will pull, the source controller will pull all of the repositories you define, but you, as I said in the beginning, you can define a notification webhook receiver in order to receive webhooks that will trigger changes. And let's see here. How would you deploy your base cluster with Flux if it doesn't exist yet? Great question. Flux has great documentation on their website about their bootstrap command. So you run the bootstrap command with access to your cluster. It will deploy everything into the cluster, set up your Git repo, and we have lots and lots of questions. All right, well, I think we're going to have to move on after that. So anyway, Flux will bootstrap it. You can also, there's a Flux Terraform provider that can bootstrap your cluster for you. All right, so, oops. As I said, I'm Jeff French from Moonswitch Software. Thank you for coming to learn about Helm, Flux, and GitOps. I hope that you've taken something away from this that you can go and apply in your projects or at your company and start having nice, consistent, easy deployments across all of your environments. I will stay back to try to answer some additional of these questions for anybody who wants to come talk, but that is my time. Thank you.